Greetings to all my dear friends. Today I meet Gohil, a student of Masters in Construction Engineering Management at SEPT University. I am going to showcase my case study on the topic of residential project as a part of integrated construction practice under the guidance of Dr. Jyoti Trivedi, Dr. Bhaga Dave, and Mr. Paramjit Lotta. Integrated construction practice. As Studio 3, the studio focuses on the application of Lean and BIM principles within the framework of integrated project delivery. We selected a residential building project situated in Ahmedabad for implementation. The collaborative effort involves assigning distinct roles to group members, with my responsibility being the role of BIM coordinator. Despite the project team at the site employing conventional methods, the portfolio emphasizes adopting the integrated construction practice approach, incorporating software-based assessment and implementation of Lean principles. To attain the project's objective, a detailed beam execution plan was formulated, outlining in detail critical workflow management processes. The model involves various disciplines, including architecture, structure, and mechanical, electrical, plumbing, firefighting services, providing a comprehensive representation of anticipated scope of work. Weekly reviews were conducted for each task, with necessary actions promptly taken. The 3D model facilitates diverse exercises such as clash detection, quantity takeoff, and site layout analysis. Utilizing softwares like Navisworks and Synchro Pro, a 4D construction sequence was generated, integrating a 5D simulation to assess cost during construction, with implementation of last planner system on the site. Today's table of contents are as follows: project brief, beam goals and risk analysis, beam execution plan, mechanical modeling, clash detection, and last planner system. Talking about the project brief, the aim and objective is to lead to integrated construction practice, where lean construction emphasizes on efficiency and waste reduction, while beam information modeling (BIM) enhance collaboration through digital representation. Together, we fostered integrated practices by optimizing people, streamlining processes, and leveraging technologies for efficient collaboration, communication, and most important, data-driven decision making in construction project with respect to save time and money and optimizing the value. People, process, and technology combine together to form integrated construction practice. Talking about the project details, it is a residential type of project. It is based on a labor contract. There are total 6 blocks containing 240 units. The total cost of the project is 110 crores. The duration of construction is 2 years. On an average, there are 200 number of laborers working on site. The total built up area is 41,810 meter square. Each block contains one basement and 10 floors. For our scope of work, we have selected Tower A, especially basement, ground floor and first floor for architectural, structural and MEPF services. Note, the basement of all the 6 towers are common, but we have considered the basement below Tower A for our scope of work. The main purpose of this project is to provide housing and living space for individuals and families. It offers a vertical solution, promoting efficient land use and creating a sense of community. Some of the softwares used in this project by us are Navisworks, MS Project, Revit, Autodesk Construction Cloud, Visilin, Synchro, Power BI, Plannerly, and Google Drive. I, as Meet Gohil, had taken up role of BIM coordinator and mechanical consultant, undertaking the responsibilities as creating BIM execution plan, design documentation and collaboration, performing clash detection, creating mechanical model for level of detail 300, creating process maps, creating a quantity takeoff for the mechanical model, and the lean implementation. Beam goals and risk analysis. Talking about the beam goals, we have distributed the project into three major phases, namely planning, design, and construction phase. We have distributed the beam uses throughout these three different phases with respect to their uses, and we have also shown their importance and the impact on the project through color coding, as you can see below in the slide. In design phase, the beam uses are site layout analysis and clash detection. In design and construction, both the phases, the beam uses will be for design collaboration, 3D beam coordination, and project scheduling. In construction phase, beam will be used for 4D simulation and 5D simulation. In planning, design, and construction, all the three phases, the beam will be used for document management and quantity takeoff. Talking about the risk analysis, we have identified 10 major risks with respect to their severity and probability. In the context of our project, several high severity and high probability risks have been identified and allocated to respective stakeholders, including human resource, technical errors, management, and planning and design errors. To mitigate human resource risk, implement technology, and ensure skilled person on site, technical error risk can be elevated through rigorous quantity and quality control measures and regular equipment maintenance. Improve management effectively by fostering clear communication channels and promoting a common database environment. By addressing this risk with the targeted mitigation strategy, we have nullified the risk for our project. Beam execution plan and employees information requirement. What is beam execution plan? Beam execution plan is a process which is developed at the initial stage of the project to use beam throughout the project, which consists of employees information requirement. Then creation of beam execution plan, which leads to beam modeling, clash detection, clash resolution, quantity takeoff, and 4D 5D simulation. For our project, there is no beam used on site and the traditional approach is followed on site. So we have interacted with project manager and the client's team to create a proposed employer's information requirement on our project. Talking with the client's requirement from beam are as follows: site layout model for the project, development of architectural and structural level of detail 300 and 400 model, mechanical, electrical, plumbing and firefighting model for level of detail 300 for the defined scope of work. Clash detection, integrating and monitoring of conflicts between structural, architectural and services model. Proper drawing coordination and document management between stakeholders involved in the project. A comparison of the quantities takeoff from the software with the manual quantities applied on the site. And at last, implementation of last planner system on the site. Talking about the employer's information requirement, it consists of three major categories. Number one, project information. Second is technical requirement, and third is managerial requirement. Talking about the project information, it consists of project details and key contracts used for the projects throughout the stakeholders. Technical requirements as software and hardware is defined and generalized throughout the project in order to create a common data environment in the project. Managerial requirement consists of standards and guidelines used throughout the project, with roles and responsibilities clearly mentioned for each and every stakeholder, with a defined meeting procedure followed throughout the project, and implemented quality checks for each and every segment of the construction. Meeting procedure is defined as defining meeting agenda, conducting meetings, discussing work status and analysis of the delays occurred on the site, taking commitments from each and every stakeholders, and preparing minutes of meeting format for each and every meeting. Talking about the beam execution plan. On our side, the traditional approach is followed and there is no beam implementation for our project. So, as a beam coordinator, I have proposed a beam execution process map and highlighted the major components as above. That is, first we have developed employer's information requirement. Then we have developed a beam execution plan. Then we have developed level of detail 300 model for architecture, structure and services. After that, we have integrated this model and performed clash detection and resolved all the clashes with respect to that. After resolving the clashes, we have developed the LOD 300 model to LOD 400 model for architecture and structure. And then we have performed the clash detection and resolution for the level of detail 400 model. After concluding and resolving the clashes, we have done the quantity takeoff and compared it with the manual quantities. And at the end, we have done 4D and 5D simulation. I have shown the detailed process map below in the slide in order to have more clarity as the inputs, process and outputs mentioned. Inferencing this, the main inference was enhancing the efficiency and collaboration. 3D model that serves project center repository of information. The model facilitates quantity takeoff and cost estimation. The beam model guides contractors and subcontractors in the execution, and real-time updates and revisions can be minimized. Talking about the common data environment, we have prepared a file naming convention throughout the project as shown below. We have also created milestone schedule for our studio work, and we have observed the actual deviation from the plan versus actual dates. We have done also distributed quality checks into four major categories as usual check, interference check, standard check, and transparency check. Mechanical modeling. Process map for mechanical model is shown below. Receiving AutoCAD files, setting base points and levels, linking CAD plans, developing designs, and at the end, having a quality check as interference check. The major elements for mechanical level of detail 300 model are the AC unit containing indoor and outdoor unit and the elevators. On the right hand side, we have shown the rendered view of the LOD 300 model. The major constraints faced to prepare this model were absence of level of details, absence of HVAC drawings, and absence of description of the elements. Hence, all the levels of the elements are assumed. After creating the mechanical LOD 300 model, we had integrated it with other models of architecture, structural and services and concluded the clash in Navisworks, and we have shown two examples of each. First example is of elevator and beam which has high severity and it was assisted to mechanical consultant and the suggestion given to modify the elevator. Second one is AC unit versus wall. As you can see the image, the wall is penetrating through the AC unit, so it was assigned to mechanical consultant, and the modification of AC unit was to be done. As an inference of this, we can say that mechanical structure and architectural parallel modeling can assist to reduce time and misunderstanding. Site visits, consultation with experts with model input are an excellent way to fix dispute. Better visualization of elements through color coding in 3D model can be done. Clashes among each models can be identified and resolved. Clash detection. Clash detection helps in eliminating delays in construction due to disputes between the design and execution phase. The clash detection capabilities, with a real-time reflection into all visuals, make the construction process faster without room for errors due to negligence during the design phase. Here, on the left-hand side top, I have shown a brief clash detection process which includes clash detection, clash grouping and assigning, clash coordination meeting, which concludes as clash resolution. The clash detection is performed in two sets to achieve structural and architectural models clash-free. The clashes of services was not resolved due to time constraint. The yellow color shows the clash detection for set 1 and the gray color shows the clash detection for set 2. Here below we have showcased few of the clashes in the integrated model, where the first one shows a clash between a beam and a column, where a column is integrated into the beam and it is assigned to the structural consultant as it has a higher severity. After clash detection, we also performed clash quantification. We have found a design error at Tower A on the ground floor staircase where clear height from a lower level to an upper level in staircase was compromised, resulting in an error to the beam's height, which initially was measured as 575 mm, and it has to be chipped and reduced to level by 100 mm, concluding it to 475 mm by the structural consultant. Here we have calculated the total cost associated with the rework, including material, tools, equipment, manpower, and inspection cost, concluding it into 1313 rupees. The major reasons for the clash observed in the project were lack of details in 2D drawings, modeling errors, and lack of availability of drawings on site. The major advantage of clash detection and quantification is to reduce cost and time overrun. It makes the model risk-free and it also reduces the waste. The clash quantification involves assessing and quantifying clashes or conflicts to determine the severity and impact of the error, creating an cost and time overrun on the project. Last planner system. Embarking on residential construction project from October 2nd to November 5th, 2023, the last planner system stands as a pivotal method poised to revolutionize the project management. Developed to enhance collaboration, productivity, and efficiency in construction, last planner system placed a strong emphasis on detailed planning and real-time communication among project stakeholders. Over the next month, the application of last planner system in our residential project promised not only to streamline the planning and execution phase but also to foster a culture of transparency, accountability, and continuous improvement. As we delve into the transformative approach, we anticipated optimized workflows, reduced delays, and ultimately the successful realization of our residential construction project endeavors. Talking about the last planner system, it contains master planning, then phase scheduling, look ahead planning, weekly work planning, and the learnings which we did. We have set a percentage planned percentage complete graph for our studio work. in which we achieved 80% or more than 80% accuracy in more than 4 weeks. The major percentage contribution of reason of variance on-site tracking was also observed, as unavailability of drawings on site, delays by the stakeholders, unavailability of MEPF detailed drawings on site, lack of understanding of the process flows, longer time required to adapt new technologies, and manpower unavailability. The last planner system is a planning, monitoring and control instrument that adheres to lean construction principle like just-in-time, delivery and pool scheduling. We have tracked the construction activity from 2nd October to 5th November, and we have used Visilin to showcase our detailed tracking. Here below we have shown an example of how the last planner system has helped us to reduce the delay from 4 day to 1 day. As in we can see in current status, on 2nd November at the 4th floor of Tower A, basically our columns are casted in two segments, which we can see on the right hand side the column shuttering is done, and on the left hand side the column is casted. Till 2nd November 2023, the 4th floor only column shuttering on left hand side was completed, and planned date of the casting of all the columns was scheduled on 2nd November, which has to be rescheduled to 3rd November as a 1 day delay is concluded. On 1st November, the casting of the right hand side of the column is done, and de-shuttering was done on the 2nd November as per the planned date. 2 days of delay is observed in both the activities. After applying the last planner system on site, the weekly schedule is prepared accordingly by starting parallel activities on both the sides of column, and delay is reduced to 1 day from 4 days. Last planner system help the contractor to get understanding of labor deployment for the delay activities on the site. Last but not the least, conclusion. Lean and BIM together were used to create integrated construction practice. As in lean approach, common data environment and continuous improvement with last planner system was used to minimize the cost and time overrun, which ultimately foster a more streamlined and effective construction process. We applied site optimization, clash detection, clash resolution, quantity takeoff, risk analysis, and 4D 5D simulation as an BIM application to this project, concluding and inferencing employers' information requirement that helps us to understand and clarify the project scope and objective with level of details and quality assurance and validation, BIM softwares and technology requirements, etc. BIM execution plan that serves as a comprehensive roadmap outlining strategy and protocol for implementation of BIM technologies. This plan ensures effective collaboration, data exchange, and coordination among the project stakeholders, ultimately enhancing the efficiency and quality throughout the construction process. 3D project modeling that use the Revit model for level of detail of 300 was prepared for visualization of model components, including their size and levels, as well as real process that should be followed on site. Talking about the clash detection, it makes it easier to efficiently identify, examine, as well as disclose interference conflict in a standard 3D project modeling during the design phase rather than execution. During the development, that aids in reducing design mistakes and inadequacies that may result into budgetary delays and problems. Two sets of clash detection were performed to create a clash-free architectural and structural level of detail 300 models. Implementation of Lean as in last planner system on the project, ensuring that work can be done in a concern of last planner system using the make ready planning. The final planners anticipate any constraint on the task that were specified during the phase planning, the planned percentage completion, and the cause of the variation were found and nullified. Thank you.